Okay, good morning to those who have just joined us. More people. All right. Okay, so like I said, today we are focusing on finishing up reflections, and that's the last transformation that we worked on, reflections. You learned how to do the reflections over the mirror line with Miss Louise. Then I went through how to use matrices to do the reflection. You multiply the matrix for that reflection by the point. You write the point of the object as a column matrix, or and then you multiply them. It is possible that you put all the points as one matrix, but you must write it in the format where the x's are at the top and the y's are at the bottom, and then you multiply it by its matrix. Recall that every single reflection has its own matrix. So if you are using the matrix method, or if your exam or your teacher or whatever activity you're doing requests that you use the matrix method, it means that you have to find out what the matrix is for that reflection and then multiply it by the points. If you are not using the matrix method, then you are using the graphing method. Now, graphing method, I'm just going to pass through it quickly in this PowerPoint because it goes through it before it does the describing. It's not going to take us long as we have done it before. Also, apart from when we're doing the graphing method, we identified some shortcuts. I don't know if persons remember the little shortcuts you identified with Miss Louise. All right, I mentioned them also again when we did matrices and reflections. The shortcuts told us little things such as if the object is being reflected over the x-axis, then the x value in the image would remain the same as the object. Remember that? And then the y would become negative. And if it is being reflected over the y-axis, then we notice that the y values will stay in the same, but the x's will become a negative. All right. Okay, so these are little shortcuts just to ensure that your answers were correct. So let me go through the PowerPoint I have here for you. We're going to review the graphing, like I said, and then we are going to go into describing the reflection. All right, describing the reflection does not take long. So as soon as we are done with that, we are going to start your new transformation, which is enlargement. Now, enlargement, I'm not going to go into all the details of enlargement. You will do that in your next class, but I'm going to introduce you to what the transformation is, and you'll get an appreciation of it before you really go into doing all the different parts of enlarging a shape. All right, or we call it dilation. All right, so that's not for us. Okay, so I told you what we're doing today. Let's begin. Turn and discuss. Which of the below is a translation and which is a reflection? That's a question to you guys. So one person unmute your mic and let me know which one you think, number one or number two, which is a
Num-
translation, which is a reflection.
number one is a translation. Number two is a reflection.
Okay, anybody else? I'll give you the answer at the end and I'll explain why. Okay, more.
Number one is a reflection and number two is a translation.
Number one is a reflection, number two is a translation. So you said the opposite of what he said so far. Okay. Anybody else? One more person? Oh, I see someone said number one is a
That's probably
reflection
true.
and number
That's
two is a
probably true.
translation in the chat. Okay. All
Yeah,
right.
miss.
So the last two answers are correct. Number one is a reflection and number two is a translation. Remember, guys, a reflection is a flip. You can see here that the two shapes look like they flipped over a line. Now we can't see the line in this case, right? But we can see that the object and the image are pointing in opposite directions. And that is one way you identify, apart from the flip, you can look at the direction that the object and the image are pointing to and you can see whether or not it's a reflection. With the translation, on the other hand, number 2, the translation is a slide. So in that case, you can clearly see that one object slid. One object slid, and that's how we got its image. All right. So if you have a question like that in a multiple choice exam, you should be able to look at them and say, okay, which one is the translation and which one is the reflection? Let's try it again. What about this one now? It's on a grid. Think about it before you answer. Look at it carefully before you answer. And then unmute your mics and let me know which one you think is a translation and which one do you think is a reflection.
Number one is the translation, number two is the reflection.
Okay, thanks for your contribution. Anybody else? I'll give the answer at the end and I'll explain.
Number
It's
one
the
is a
same thing she say.
translation, and number two is a reflection.
Okay, so everybody so far, we have 3 contributions so far, and everybody is saying the same thing. Okay, yes, and also in the chat, we have the same answer here. Okay, and you are correct. Okay, why is number 1? They both look the same. They both look like they are being reflected, in my opinion. But you are correct, they are not both being reflected. Number 1 is a translation. It is a slide. The only thing is that it only slid to the left. Because this one here, the second one, is your object. How do I know that's your object? Because it has A, B, C, and D. It does not have the prime. So I know this is my object and I slid to my image. Now, in that translation, they slid left or right, in our case left, but they didn't go up and down. And that is why it ended up being on the same level as the object. Now, someone may say, but isn't it if I drew a mirror line right here in the middle, wouldn't they be the same distance away from that mirror line? No, because let's look at where A is and where A prime is. If I were to draw a mirror line, follow me guys, watch the screen. Watch the screen. If I were to draw a mirror line, oh, straight down here, see my cursor? That's where the mirror line would be, because it have to be in the middle of the two shapes, in the middle of the object and the image. Now, if I were to draw that mirror line right here, look at how far A prime is from the mirror line. It's about 1.5 boxes. If I were to draw the mirror line right in the middle here, it's about 1.5 boxes. But look at where A is. A is 1, 2, 3.5. That's how far A is from that mirror line. You see that? And so when you see something like that happening, you have to say, oh no, that it looks like a reflection, but it cannot be a reflection, because a reflection has the image and the object. They have to both be the same distance away from my mirror line. Because if you were to do the reflection yourself, you would say, okay, I count 5 A's, 5 boxes or units away from my mirror line. So my image has to be 5 as well. That's what you would see. So in this, if anybody else were to do a reflection, they have to say the same thing. And in that case, the object and the image are not the same distance away. Instead, let's look at this one here too. Number 2. Instead, this one here is your, sorry guys. This one here, sorry guys. This one here is the reflection, because the mirror line in that case is which line? Can anyone tell me?
Miss X.
Right, the x-axis is our mirror line. And so you can see C, let's look at C, is just 1 box away, and C prime is just 1 box away as well. D is 1 box away, the D prime is also 1 box away. And the same thing will apply to A and B. So this is clearly a reflection. They are the object and the image are same distance away the same distance away from the mirror line. All right. So a translation is a slide, that's the answers, that moves a figure to a different position, left, right, up, or down, without changing its size or its shape, and without flipping or turning it. You can use an arrow to show the direction and distance of the movement. All right, or you can do it on a graph as you see here. Now, these were the answers to the two questions I asked you previously. The second one, a reflection, a flip, it creates a mirror image of a figure. All right, a mirror image. So as you can see, your answers were correct. So let's begin the real stuff now. So, quick revision. A reflection is a flip because the figure is flipped over the line. Each point in the image is the same distance from the line as the original points. So A and A prime are both 6 units from the line T. So here, just a quick revision, 1, 2, 3, 4, 5, 6. The other side, 1, 2, 3, 4, 5, 6. Okay, and remember I told you that if you ever do a reflection, what you can do, you can fold your paper, the graph you use, on the mirror line, fold it exactly on the mirror line, and you'll notice that all the object and image corresponding points, the corresponding object and image points would actually touch each other. Okay, in this PowerPoint, they refer to the object as your pre-image and your image as your image. So don't be confused. Sorry, don't be confused because sometimes that vocabulary is used instead. So you see, it says check to see if the pre-image, meaning that they're talking about the object, and the image are congruent. Does anyone remember what I said congruent was the last time? That word congruent. I think I have very good. Equal. More. There's more to it though. Equal something else. Somebody responding in the chat. Equal. What else? Okay, so equal is correct. Equal, same shape, same size. Very good. Same shape, same size, equal. Same angles, same length of the sides. So if AB is 5 units, in that case, this AB is 1, 2, 3, 4 boxes long. If AB is 4 boxes long, then A prime, B prime has to be 4 boxes long. Okay? Because it is congruent. So now congruent is not the same as similar in mathematics. When you say similar, you may try to think like similar also means the thing is the same. But in mathematics, similar just means that it would have the same shape, but not necessarily the same size. Now, when we go into similar and congruent, you'll get more information about that. So don't confuse yourself right now. Okay, so what they said here is that notice that the image, which is here, and the object or your pre-image are congruent. They are the same size, same shape, everything. Okay. How would you reflect this figure across the y-axis? Somebody tell me, because that's a revision.
We should have to use the matrices. I don't know.
Right? You can use matrices, but if you use matrices, you have to identify the matrix for the y-axis. In this case, I want you to use the grid. How would you reflect this across in this grid here, across the y-axis? You can continue if somebody else wants to do it instead. That's okay.
Yes, you use the type of reflection and then you just take the coordinates of A, B, C, and D. And then you get the equation, like you find it out, and then you plot it on the other graph, on the other side, and then you just count your boxes and stuff.
Okay, tell me how you count the boxes, because that's what I'm really interested in this revision.
I beg your pardon, miss?
How would you count your boxes? That's what I really want you all to tell me in this revision. How you would do it on the graph, meaning that how you would count your boxes.
Yes, you just you're taking the points. My mic was muted, sorry.
Yes.
You're taking like the points and then you counting how many boxes it is away from the mirror line. After
Okay.
you find your equations and stuff like that, just to check to see if it's accurate.
All right, very good. Okay, and also we got a good contribution as well in the chat. Very good. So you count the same distance away. So let's start with A. A is 1, 2, 3, 4, 5, 6 away from the mirror line. This here is your mirror line, guys. You must always identify the mirror line first. So let's start over. They said the y-axis, this is the y-axis. Y-axis is also the mirror line called x equals 0, right? Why do you think it's called the line x equals 0? Did Miss Louise go through it with you? If not, do you know? If you went over it, if you can someone tell me if what they recall?
I beg your pardon, miss?
Why is the y-axis mirror line also called the mirror line x equals 0?
Miss, I don't know. Me tell us.
Okay, no problem. All right, it's also called the line x equals 0 because notice the y-axis passes through the x-axis at 0. This is the x-axis, right, everybody? And this is 0 here in the x-axis, right in the middle on this graph. It's right in the middle on this graph. Notice that the y-axis, that the vertical line here, it passes through the x-axis exactly at 0. And so that is why we call that line the line x equals 0. In the same manner, if you have a line that was passing through x at 5, what do we call that line?
I beg your pardon, miss?
If we had a mirror line that was passing through the x-axis, through the value 5 on the x-axis, what would we call that mirror line?
X equals 5.
Very good.
X
X
equals
equals
5.
5. And so because the y-axis passes through the x-axis at 0, we can also call the y-axis the line x equals 0. Okay? All right. Just a quick revision, and it came up in a
Understood.
response. I wanted to make sure everybody knew what to do. Okay, very good, guys, so far. So let's look at what the answer will look. When you identify your y-axis, then you count how far it is from the y-axis. So in A's case, it's 1, 2, 3, 4, 5, 6. And on the other side, you must also do 6. 1, 2, 3, 4, 5, 6. You count B. B is 1, 2, 3. To get B prime, on the other side, you do 1, 2, 3. Same distance away. All right. And so this is what your image will look like. So C. Okay, please mute the mic so everybody else can hear me. All right, so C is 1, 2, 3. And so C prime would be 1, 2, 3 on the other side of the mirror line. D is how far away? 1, 2, 3, 4, 5, 6. And so D prime will also be 1, 2, 3, 4, 5, 6 away from the mirror line. Okay? And remember we said that we can also identify what the image by looking at the x and the y. If it is over the y-axis in this case, then you know the y stays the same. Look at what the PowerPoint has, and what happens to the x's. The x value would change. The sign of the x value would change. Okay. So this is the x-axis. The same thing would happen if the x-axis, guys. All right, same distance away. You first identify the mirror line, which is the x-axis. What's another name for the mirror line? Anybody? Another name for the mirror line. Remember another name?
Y equals 0.
Very good. Y equals 0. So with the y-axis, we also call it x equals 0. With the x-axis, we also call it y equals 0. And can someone tell me why we would decide to call the x-axis y equals 0?
It's
Y
because
passing through the x-axis.
at 0.
Add 0. Very good. All right, the contributions look very good. You'll help each other there. All right, so because the x-axis actually passes through that y-axis at 0. So we also call the x-axis the line y equals 0. Okay, you did all of that already. They said reflect this ABC over across the y-axis. So in that case, you are going over the line x equals 0. You would count this distance away, 1, 2, 1, 2. So we're not staying on the graph, people. Does anyone want me to go stay on the graph 1 minute? Or can we move on because you've done it before?
Miss, we can move on.
Okay, so everybody understands that you must find the mirror line and then count the spaces from the object to the mirror line, and these same spaces, you count them for you to get your image on the other side of the mirror line. Everybody understands that?
Yes, miss.
Yes, Miss.
All right, so we are going to what we really had to do today, which is describing the reflection. Now, when we describe a reflection, we have to say, first of all, that it is a reflection. But you would say, if I'm describing a reflection, why I have to say it's a reflection? Because when they ask the question, it would tell you, describe the transformation that maps, most likely, let's say ABC to A prime, B prime, C prime. They're not going to tell you describe the reflection. They're going to tell you describe the transformation. Now, there are 4 transformations. Just like when we did the first activity, when we started, you told me whether the examples I had were translations or reflections. In the same way, you are supposed to look at the transformation and decide whether or not it is a reflection translation. Later on, you will be introduced to dilation, or even later on, you'll be introduced to rotation. Okay? Now, in our case, we are focusing solely on our reflection. When the transformation ends up being a reflection, you have to say, 1, the transformation is a reflection. That's 1 mark already, just saying it's a reflection. And secondly, you must identify, or you have to name, the mirror line. You must be able to name its mirror line. Okay, now let's look at this shape here, these 2 triangles I have on the screen here. Did everybody identify that it was a reflection?
Yes, miss.
Yes, miss.
Yeah, because can see they are
Yep.
pointing in opposite directions, and also you can notice too that there is a mirror line, and also you notice that they are same distance away from that mirror line. Now this line is not the x-axis, it's not the y-axis. Instead, it is called the line x equals 3. Do you agree?
Yes,
Yes,
miss.
miss.
Okay. We agree that it is x equals 3 because, can someone tell me?
Miss, y passing through the x-axis at 3.
Right, the line passes through the x-axis when it is 3. And how do we know this is 3? We counted 0 is in the middle, then 1, 2, 3. Very good response. Okay, so in that case, if you were to describe that reflection, you would say the transformation is a reflection over the line x equals 3. See how they have it written? This is a reflection over the line x equals 3. That's all, and you get your marks. That is what we say when we in the objective describing a reflection. Let's do this one here. All right, this is again is another reflection. You can see they are pointing in opposite directions. Okay, so when you are describing it, you have to see this is a reflection, 1 mark, and the mirror line, in that case, they say the mirror line is y equals -2. Do you agree?
Yes, miss.
Yes, Miss.
Why?
Because the mirror line passing through -2 on the
Two.
y-axis.
Very good, because it
Yeah.
passes through -2 on
Agreed.
the y-axis. All right, so that is what reflection is all about, guys. Saying it's a reflection, naming the mirror line. So let me see if we have another activity here. No, that one wants you to, right. That one wants you to reflect over the line x equals 2. Where will x equals 2 line be? Can someone tell me?
Miss
X equals 2.
Miss,
The mirror line
above,
passing.
above the zero at the top on the positive side.
Are we using this 2 here or this 2 here? Which
Miss
line are we
bottom.
The two
drawing?
on the
Two here
positive
or
side.
here?
Yes.
Where? Which two?
But I can
On the
point
positive.
The positive.
But both of them positive. Here is
The
positive, here is
bottom.
the
positive.
positive
Miss
Okay,
two
so
on the
going up.
right here.
x-axis, miss.
Okay, good job.
Your right
Right on
side.
the, all you have to say is on
Right
the
side.
x-axis, Missy. That's all.
When Miss I said that.
Yes, that's why I repeated it. Okay, good. That's all everybody else had to say, I meant. I should have said it that way instead. Okay, so what about this one here? Y equals 4.
It's 4 on the y-axis.
Right, so the line would be vertical or horizontal? Will the line be horizontal
Vertical.
or vertical?
Vertical.
Miss vertical.
Vertical means it's going from up to down, up and up.
Horizontal.
Horizontal, because it goes this way. All right, just like the
Oh,
horizon. Yes, horizontal.
Miss,
All right.
sorry. I
This
just
talk man, you're the fool in the chats.
Okay. Vertical row. Okay. All right, guys. Thanks for the contribution so far. Okay, now again, another description. Now, when you look at this one here, guys, will it be easy for you to see the mirror line?
No, miss.
It's not easy to see the mirror line. And so now I'm going to give you some, you can take a few notes. Once you have your notebook, you should have your notebook with you, on how you would do it in case it looks a little confusing like this one. Now, first of all, you can already see that's a reflection, because notice that they look like they are pointing in opposite directions. This pointy part here is going this way, and this one is going the other way. So once you see they are pointing in opposite directions, you know already it's a reflection. But then you will say, but what the mirror line is, because I cannot see that mirror line. Okay, what you do is that you choose one object and its image. I'm repeating myself. You must choose one object and you choose its image. So in that case, they're not labeled, but I will point for you. So look, I am choosing this object here and its image here. You notice these two are the corresponding points?
Yes, miss.
Right, you can choose this one up here if you want. And that means if you choose this one, that means the next one you have to choose on the other shape would be here. Okay, so what you have to do is, first of all, choose an object and its image, its corresponding image. When you do that, you have to count the distance between the two of them
And divide by
And
and
divide by
divide
2.
by 2. Very good,
2.
guys. So is it confusing anymore?
no,
No,
miss.
miss.
So, and when you do that, you just draw the mirror line and then you can name it. Okay, so let me count mine. So it's 1, 2, 3, 4, 5, 6. So 6 divided by 2 is 3. So that means my mirror line is 3 boxes away from either my image or my object. So let me use this one here. So 1, 2, 3. The mirror line is right here. If I use the other side, it will be 1, 2, 3. The mirror line is still right here. And that line here passes through the x-axis at -1. So that is why they say it's a reflection across the line. X equals -1. Any questions on this one?
No, miss.
Okay, let's go to the next example. All right, look, we have 2 more here. Can someone tell me? This is a reflection, yes, in what's the mirror line?
The mirror line is
Y equals 0.
A.
yeah.
Y equals 0. Very good, on the x-axis. Did everybody see that mirror line was y equals 0?
Yes.
I see x equals 0.
Okay, so x equals 0 would mean that the line is passing through x at 0. That would be this line here. But the
Miss,
line the reflection is happening in is here.
Miss, I want to say like how is y and is x? That's a mirror line.
Right? The mirror line is x-axis or the line y equals 0. It's the same thing. It's just two ways of naming that line. And that's why I went over it earlier. I said we call it the line y equals 0 because it passes through the y-axis at 0. So if someone on their exam or their whatever activity you're doing, you write, it's a reflection in the x-axis, I give it to you correct. If you write for me, it's a reflection in the line y equals 0, I also give it to you correct because they both mean the same thing, okay? So you would say what is easier for you to remember or what you
Miss, that's why
what you
I'm saying it because
understand.
that is confusing me.
Okay, so for the x-axis and the y-axis, you can keep them as saying their names, but for the other lines, you have to be able to say whether it's y equals 4 or x equals -3. You have to be able to say it for the rest, okay? So you'll have to practice that one. So why is it the y-axis here? I'm going through your answer because when we look at A and A prime, we notice that they are 2 boxes away from each other. Half of that is 1 box away, meaning that the mirror line would have to be in the middle here. 1 box away, 1 box away. That's my mirror line here. All right, let's look at this example here. What is the mirror line in example, the one that's labeled 6?
X equals 0.
Very good. So the mirror
0.
line here is the y-axis or the line x equals 0. All right, look at another little question. Which of the following represents a single reflection of figure 1? Which one, A, B, C, or D is a reflection of figure 1?
It's B.
B.
Very good.
B.
B. Very good, guys. So you all understand the reflection. What about
Yes,
here?
miss.
Describe the reflection below. Across which mirror line?
X axis.
X.
That's on the x-axis, eh?
The y-axis.
People, I
Yeah,
just saw you
Y.
all out. Did you count how many boxes between A
X
and
is
A
equal
prime?
to 4. X is 4. X equal to 4.
The answer is x equals 4. Let me explain it. So when they ask you for a mirror line, you must count the distance between the object and its image. So I'm choosing A. So you see 1, 2, 3, 4, 5, 6 spaces between A and A prime. When you get the answer, you told me that you have to divide by 2.
2.
So if I divide by 2, I get 3. So you count in 3. So 1, 2, 3, and that's your mirror line here.
So
So
y
X
equals to
equals to
-3.
So that means that point here would be, let me count, 0, 1, 2, 3, 4.
4.
4. And it passes through which axis?
X.
The
X.
x-axis.
So the line is x equals 4.
X equals to 4.
Right. So the person who said x equals 4, you are correct. So let me do it again one more time. You have to choose an object and an image. I'm using C and C prime this time. So you count how far away they are from each other. So 1, 2 away. So when you get the distance they are away from each other, you divide it by 2 because the mirror line would be in the middle. So that's why you divide by 2. So you divide by 2. 2 divided by 2 is 1. So you counted 1 distance away from C. So 1. So that means the line comes here. Right? You draw the line and then you count. Sometimes it might be numbered for you already, but now I guess we have to count. So 0, 1, 2, 3, 4. And then when you see it's 4, you try to identify what is 4, x equals 4 or y equals 4. How do you know?
Which watching the axis sit on?
Right, you watch the axis it's on. So in that case here, the 4 we identify is on the x-axis, so the line is x equals 4. Anybody have any questions about that one?
No, me.
Okay. All right. Look,
Nope.
another question for us to review. Describe below the reflection of 3, -7. It goes from 3, -7 to -3, -7. Which one is it, A or B?
B. No, A.
Be
It's
sure.
B.
B.
Miss B.
B.
I figured it should
Let me
be.
see the chat have some answers.
is.
B. Okay.
I know which one to be honest.
You're not sure which one? Okay, well, I'll explain the answer when I say what it is. Okay, so the answer is B. And you are correct. Very good, guys. Now, why is it B? Because when you reflect in the y-axis, the y value stays the same. But
Yes,
the
miss.
x value, if it is positive, it becomes negative. If it was negative, it becomes positive. So I'm repeating that again.
Oh,
If you have a reflection in the y-axis, your image and your object will have the same value as your y. So remember your point, this is x, this is y, this is x, this is y. Notice the two y values in the object and the image are the same. And so that means that's the reflection in the y-axis. If it was in the x-axis, then the x values will be the same. Okay, people, so next
yes, miss.
question.
Understand.
All right, so we have a whole set of questions. Okay, number 1. What is the difference between a translation and a reflection?
Miss, I can answer.
Yes, go ahead.
Miss, a translation is Miss, when the object and when the object slides, Miss, and a reflection is a flip when you flip the object.
Very good. Very, very good. I have nothing to change here. Okay, good response. Number 2, who wants to try number 2?
I'll do it.
Okay, go ahead.
Okay, how do you perform a reflection? Okay, first things first, you have to find your object. And from there, after you find your object, you have to find the mirror line.
Mm-hmm.
Right after you find your mirror line, you have to count the amount of spaces on each point on your object, how far it is away from the mirror line.
Mm-hmm.
When you get your point, you're reflecting it over the mirror line with the point you got. Like let's say if A is 4 points away from the mirror line, you do it for A prime, and
The
then you
same
get
4
your answer.
points. All right, very good. Okay, that was a good explanation as well. All right, number 3. Will a reflection always result in a congruent figure?
Yes, yes, it will.
The answer
Yes,
is yes, yes, and yes again. All right, also for translations too. Translations always have a congruent figure because they will be the same shape, same size, same everything. The only thing that's different is they're not in the same place anymore. But then everything else is good. Okay. So number 4. How would you complete this if it was a reflection over the x-axis?
Miss 9 and -3.
Very good. The x's stay the same and the y's would change. Number 5. Somebody, how would you complete this if it's a reflection over the y-axis?
Miss
Negative
-9
9.
and -3, I meant.
Very good. -9, change the x and the y stays the same. And our last question, mute your mic, I'm hearing some background noise. The last
9
question,
-3.
how do you describe a reflection?
Miss, you describe a reflection when the object and the image are pointing two directions. So this, yeah, I
Right,
enjoy that.
that's good. That's when you identify that it is a reflection. But in your exam, if they tell you describe a reflection, what would you say?
Y equals whatever the line stops on. Or
Okay,
X.
you missing the starting part of your sentence. It is a
or it is
It is congruent.
People, you all know the answer. You're making it confuse you. It is a reflection. It is a
reflection
reflection.
equals
Because you don't get the
X.
point unless you say it's a reflection. You have to say it is a reflection. Because remember, there are 4 transformations. So it is a reflection, good. And then what's the next part? You were saying it.
X equals whatever line is stopped
Right.
on, or
Right. Then you say
Y
what your
equals
mirror line is. Good. So if it's x equals something, if your mirror line is the y-axis, you say y-axis. If the mirror line is the x-axis, you say x-axis. But you have to say what the mirror line is so you can get your full marks. So I like all the points that you'll give me for that question. First of all, you have to look at the shape and see if it's a reflection. So if you see they pointed in opposite directions, that's the first contribution someone gave. So you look at it and you see if it's pointing in opposite directions, it's a reflection. Good. Then you start to write. You say it is a reflection. And then you say the same contribution that someone gave also, they said, then you say it's x equals whatever, y equals whatever, meaning that you are saying what your mirror line is. Okay, guys, so I think everybody has a good grasp on what a reflection is. Okay, so for the second part of our session, we are going to go into dilation. I'm going to allow everybody to take a 2-minute break. So if you need to go to the bathroom, you can do so quickly. I'm going to go and get a cup of coffee. Okay, so do that 2 minutes, and then we're going to come back. Let me share the new screen. And then we're going to do our dilations. Remember, it is very short because I'm not going into all of dilations. And plus, I know you're probably have to try to remember how to name the mirror line, different things we just in reflection. I don't want to overwhelm you. So we're just going to introduce what it is. And then next class, you'll really go into what everything in it. All right, so go and take your 2 minutes break. I'm going to take mine now.
Boy, Miss Winter, you don't change talk show by the thing already.
Okay, guys, so we are continuing from.
I didn't even get a break.
You didn't take your break? No?
All
Okay, but you'll get a
all
break pretty soon because our class is going to end in the next about 40 minutes. Okay. So
no,
we are starting on dilations. And if we finish before,
Of
I
what
will
a
let
class.
you go before. Okay? Because the PowerPoint is not long. All right, so dilations. What is a dilation? Did you see the effects that this had? Okay, let's begin so you can see the effects. What just happened there? Can anyone describe to me what just happened?
Means
Let's do that again.
the globe
Okay.
shrink.
Yes, it shrunk. That's what happened.
Means that's reduction or whatever we call it that.
Right. So that was a reduction that just happened here. Okay. Very good. So everyone, you will correct. Your responses were correct. Okay. Bye. Oof. All right. So dilation. A dilation is a transformation that produces a figure similar to the original by proportionally
Can
shrinking.
you say that
Or
again?
a dilation is a transformation. It's on the screen. Can you see my screen?
Yes,
Yes,
miss.
miss.
I don't
Okay.
Yes,
know.
miss.
So it produces
Sister,
a.
look on the TV.
Beg your pardon? Okay, so it
Not
produces
saying
a figure similar to the original, meaning the object and the image, they are similar by proportionally shrinking or stretching the figure. So in our case, we saw shrinking taking place, shrinkage. Yes? The earth
Yes, miss.
got smaller. And that's how it looks, when you really when people look at it from pictures and whatnot, when they go up in space, they see it smaller than it really is, and that is a dilation happening right there. Okay, so let's continue. Look at your pupils. What happened here?
Is it open, miss? Enlargement.
Right, so in
When
that
light
case,
enters your eyes, your pupils shrink, and when light does not enter, like let's say in dark or something, like it expands.
right, so we say it's dilated, right? It's a dilated pupil or undilated pupil. So all of that is real life examples of dilation. What just happened to our PowerPoint slide?
Is it reduced?
Right, reduced. And so a dilation, who in this case they use pre-image for object as well. So the image and the object are similar, but the dilation is not an isometry, meaning that they will not be exactly the same. Okay, it's similar but not exactly the same. So when a figure is dilated, it must be proportionally larger or smaller than the original. Now notice they keep on using the word proportional, all right, because it has to be done in a certain manner. It cannot just be done anyway. If you have in a shape, you know your shape has points when we do it on a graph. And so if you enlarge point A by 5 and then you enlarge in point B by 3, then the image will not end up looking like the object. And that's why they keep on saying it must be proportionally larger or smaller, because everything must enlarge or shrink in the same way, all right, or with the same scale factor.
It's not ratios using for that.
So yeah, we can use a ratio for it. If you look at it, it's really a ratio that's happening, But when the question is being asked for CXC, what they do, they give you a scale factor, just like when you did scale multiplication in matrices, where you had one number outside the bracket and you have to multiply that one number by everything. Remember that? If you had 5 outside the bracket of the matrix, you have to say 5 times the 1, 5 times the 2, 5 times the 3.
Yes, miss.
Right. And also remember when you did trying to prove if vectors were parallel or if they were collinear, you have to show that they were scalar multiples of each other, meaning that a number multiplied by whatever it was would give you back the same answer. If you don't remember that, you'll have to go and review it. You'll just do that this term. But anyway, it's the same concept of multiplying one number by all the other numbers. In your case, it will be points. So with a dilation, you'll have the same shape. The only thing that will be different will be the scale, and also the size will be different as well. They don't have that there. Okay, so let's take a look. We have a circle with a certain diameter, right? The diameter is white on the red circle. What's happening here?
It shrink.
It shrink. And what happens to the diameter? It
It stays the
also
same. Shrink.
Right.
It shrink.
It shrink as well. So you decrease the size of the circle, and so you decrease the diameter of the circle. All right, and of course, increasing the circle would do what? Increase the diameter of the circle. So the same thing happens. You increase it, everything else increases as well. That's all dilation is about. Showing you how to get a shape bigger or showing you how to get a shape smaller. All right. So we always have a circle, so same shape with a certain diameter. We are just changing the size or the scale. So that's what they were trying to bring about in these examples. Let's look at some real life examples here in terms of pictures. All right, we have milk, we have Simpsons, we have hints, same shapes, different size. Okay, we have the snowflake here, and we have ducks. Which of these are dilations? Now remember the hints they just gave you.
C and B.
C, B,
E and C.
C and B. That's
C
it?
and B.
Why? Tell me why.
Because the same shape but
This
different
Because
size.
they're just not the same.
Because everything has to be the
Same.
same. So A, they don't look like the same thing?
No.
No.
They're not the same. You can see the way it's curved, the way they form the bottle, the handle small,
Yes,
the
miss.
handle. All right, and what about D? What happened to D?
means that's two different ducks.
Yes, that duck over there has his legs kind of like it's swimming. It's one on top of the other, like going, I don't know. And the other one, and that's your baby and that's the mother anyway. So that's not a dilation. A dilation is just getting one thing bigger or one thing smaller. So you are correct. Look at this. Okay, you are correct. Your answers are B and C. Good job, guys. So let's talk about the scale factor. Now that you understand what a dilation is, it must look the same. It's just that the size that changes. What is the scale factor? The scale factor is what makes the shape bigger or smaller. Now, how? If the scale factor is larger than 1, then the figure is enlarged. And did I have to even tell you that? That's common sense, right, guys? If the scale factor is 2, I'm telling you I'm enlarging a picture I have by 2. I'm telling you I want it twice the size. That means my scale factor is 2. Do you expect me to come from the Photoshop with a bigger or smaller picture?
A bigger picture.
A bigger
The
picture.
picture, right? So that's what it's saying here. If the scale factor is larger than 1, then the figure is enlarged. Now, if the scale factor is between 1 and 0, what numbers lie between 1 and 0? What type of numbers? If a number is less than 1 but more than 0, what type of number is that?
Is decimal.
Negative.
Decimals or
Decimal.
fractions. No, negative and negative will be after the 0, right? So when you have your number line, you have all your positives, you have your 0, and then you have your negatives. Okay? Or if you want to look at it as you would have it on the Cartesian plane, you would first have your negatives, then you have your 0, and then you'd have all your positives. So, but then if you have to look between the 0 and the 1, that means it's less than a whole. That means it's a part of a whole, meaning that it's a fraction or it's a decimal. So basically what they're saying here is if the scale factor is a fraction or a decimal, then the figure you have is reduced, meaning that it is smaller. Scale factor more than 1, bigger. Scale factor less than 1, smaller. You see how they change their shapes?
Yes,
Yes,
miss.
miss.
Okay. All right, so are the following enlarged or reduced? Hold on. A, if you have a scale factor of 1.5, is it enlarged or reduced?
Enlarged.
Enlarged.
Right, because it's
Enlarged.
more than 1.
1.
Very good. So that's how it would be 1.5 more, that's what it would be. All right, let's look at B. Scale factor of 0.75. What would happen?
Less than.
Okay,
Reduced.
it's less than, so it will be reduced. So what do you expect
Reduced.
to happen to the picture of the elephant?
That's
Get
smaller.
smaller.
Smaller. Right.
Smaller.
What about C? Scale factor of 3.
Enlarging.
Enlarged.
Enlarged. Like really big. So let's see. 3. Whoa. Okay.
That almost swallowed my head there.
Yes. Math is all right. And what about D? Scale factor of 1/5.
Enlarged. More
It's
than 1.
small. Small.
Hopefully it's
1/5.
reduced.
Come on, man. Reduced.
With
It's smaller.
reduced because that's a
Reduced.
fraction.
1/5 is a
Smaller.
fraction.
Oh,
1/5.
that's oh.
Yes, yes, yes.
Yeah. So redo. Can you even see that? So
Yeah.
that's really small. Okay. 1/5 is the same. What decimal?
2.5.
0.2. 1/4 will be 2/5. But good try though. Okay. Okay. So these are dilations used every day. In our everyday life, these are some of the dilations we meet. So look at this arcade here, the first one. This is a giant representation of a small game, right? So normally when you go to an arcade here, you would see that it would be a regular size. But in this place here, they have this giant game where people have to actually climb a ladder to play. And that is very cool, in my opinion. Okay? And here now, these are the little cars. You know, people collect these little cars. They look exactly like the real big cars. But that's a collection that some persons have. And these are dilations. They are reductions of the real cars. All right. So, and how did they do that? They use a scale factor. They use the concept of dilation. Let's look at this here. I'm not even sure where that is, but this is a giant chair. So much so that a car is packed underneath it. And so that is a dilation of a chair. You see that? And that's actually in real life that they made that huge. A huge structure of something that is usually a regular size. So it's a dilation. What about a map? Isn't a map a dilation?
Yes, miss.
Yeah.
Why is it a dilation?
Because it shows the country smaller on a paper than on a globe, but in real life.
Right, because in real life, these places are so huge, right? But then they need to show you how to smaller version for you. And so it's a dilation. The same thing here with that image here. This place is a real big place. But then for you to understand it, they will make that model smaller so people can interact with it in case they, if they're doing the designing and they need to make changes. What about that huge burger at the back here? Is a burger ever this huge?
And
No,
large.
miss.
No,
It's
miss.
Yes,
enlarged.
and large. So okay, and makes the experience at whatever hotel that is, makes the experience better for persons that seen this large burger. So persons really use dilations in our everyday life to make things.
The toy burger that day.
Yes, it's not real. It's just a model. Okay, so these are examples of dilations in our everyday life.
Miss them and enlarge too.
What's enlarged? Say it again.
Put me out of the class, miss. Put me out of the class.
No, I didn't hear what he said. What did he say?
Go back
Okay,
to
so
the picture.
all right, so let's go into some
Yeah,
real
like
work
a
now
fool.
that we have understood what a dilation is. Real work now. All right, so the dashed line in the figure is a dilation image of the solid figure. So notice you have a solid figure and then you have a larger figure from that small figure. The labeled point is the center of dilation. Tell whether the dilation is an enlargement or a reduction, then find the scale factor of the dilation. Now, before we start doing the activity, I have to tell you exactly how you find the scale factor of a dilation. So if you were to find a scale factor of any dilation, you would divide. What would you divide? You would divide. Anybody wants to tell me what they think you would divide?
Yes, miss.
The number of
Miss.
sides.
One person.
Jamal
Yeah,
go.
Um.
Just repeat.
So, miss in the exam, like miss, how it is coming? We
That's
move number.
that's one way. And then that's why I said today we're just going through the introduction of the whole concept, and next time we'll show how to actually do the dilation. I'm going to show you how to do the introductory examples of it as well. But then the real, like when you have to do some extra work, it will come next time. Okay, but then let's go through that one because that comes up as well. How would you find your scale factor? You would divide. I already gave you a hint. What are you dividing?
Is the number of sides.
Miss. When you find in a dilation of dilation, you taking the small one and you dividing by the bigger one. When you
No,
find it,
by the image.
It's
yeah,
actually
look at
the
the
image divided by the object.
object.
Yes,
The
image
image
divided by object. What did you say?
The image is the darker one.
In that case, they said that the dashed line figure is the dilation image. So the dashed line is the image. So the solid lines are the objects. The solid lines are what you started with, and the dashed lines shapes are what you ended up with.
Is that obviously?
No, but someone asked, so I'm
Oh,
clarifying for them. Okay, so let's work through it. Number one. What is that? Is that an enlargement or is that a reduction?
enlargement.
Enlargement. Okay, we had a small triangle and then we end up with a big triangle. Notice that the shapes are on each other. That doesn't always happen, but in our example, that's how it is, and I like that it's so anyway. All right, so notice that the image is actually ended up on the object in some way. All right, so that they look like they are merged in such a way. All right, and that happens sometimes. So what will be the scale factor of this example? What did they do to 4 to get the 8?
Multiply by 2.
They multiply by 2, meaning that your scale factor is 2.
2.
All right, how would you calculate that when you are showing your working? You are supposed to divide. What are you dividing?
8 and 4.
8
The
and 4,
image
right?
from
The image divided by the
object.
So 8 divided by 4 is
2.
2. Very good.
When you
So our
multiply
scale
4 by 2.
factor, right? So 4 times 2 gives me 8.
8.
So our scale factor in that case is 2. Let's do example 2. Example 2, notice something before you start working. You are looking at the corresponding sides. So you are looking at here, the 3 and the 6. But notice that is 6 the whole image? Is 6 the whole length of the side of that image?
Yes, miss.
No,
miss.
What's the full length of that shape here on that side by D?
It's 6.
9.
It's actually 9.
9, yeah.
Right, the full length of the image, because we're looking at the bigger shape. The full length of it is actually 9. But the length of the smaller shape is 3. So what would be the scale factor in that case?
Well,
Miss Free.
The scale factor is 3. How did we get that? We divided.
It's 9 and 3.
3 divided by 9.
9 divided by 3.
Divided by 3.
Right, 9 divided by 3, and our scale factor in that case is 3. Good. Now, people, that is something that comes up often where persons will get it wrong because they only see the 6 and they don't notice that the 6 is actually only part of the image because the image continues. So let's not make it happen to us, okay? All right, so go ahead.
Number 1 is the 4 passing it.
Because look at where the 8 was for the 4. The number 1, the 8 was there by itself. It did not join in. It was there independent.
Oh, okay.
This, yeah, but that one ended up being on it, and the points they gave us, the measurements they gave us, they gave it to us on it as well. Okay, and that was done deliberately too, for you to see it for yourself in that manner. Let's do number 3.
Reduction.
Right, it's a reduction. Okay, someone said the scale factor is 2/3. Do you agree?
Yeah, partner.
Someone said the
Miss no. 2/3.
2/3. Do you agree?
Miss no.
No.
Divide image by object before you answer. What's the 2 corresponding sides you have? You have the 2
Miss
top.
it will be 3.
Miss 3.
3, that's the answer.
Let's divide. What's our image?
6.
6.
9.
Full length. And what's the object? 9. You have the full length. You have nothing to add to it.
Hey, Miss 2
Right, very good. So the answer is correct. 2/3 is actually correct.
Yes, miss.
Okay, and then you expect it to be a fraction too, people, because that's a reduction. That's a big shape because the solid part is the shape. And then look at the dash line figure. It's smaller. So if it's a reduction, you expected your scale factor to be a fraction. Let's look at number 4. Enlargement or reduction?
Enlargement.
Enlargement. Very good.
Enlargement.
And what is the enlargement? What's the scale factor?
Miss,
2.
1.
The scalar is 2.
4 divided by 4
yes,
is
miss.
1.
2. Miss,
1.
miss.
Miss, 4 plus 4 is 8. Because
8.
the 4 you see in there is
4
the
divided
side for that piece, and the other 4 is the side for the other piece. So you add the 2 and you divide by 4.
Right. So in that case, you had to add the 2 4s because you only had a piece of the image side. You didn't have the full side.
Yes,
So
miss.
you had to add 8. You have to add 4 plus 4, giving us 8.
8 and then divide
All
by
right,
4.
that would be our image over the object. In that case, is just 4. So our scale factor here is 2. So the image is actually twice the size of the object you have here.
Yes, miss.
All right, does anyone need us to repeat the explanation?
No, miss.
Okay,
Just
all right.
repeat
So
number 4. How you get number 4?
number 4, can someone explain
please.
to her?
Yes,
You
miss.
add it
Uh-huh.
and then you divide the image by the number.
For the
Okay.
object.
But
All right, very good. So image divided by object, you added to get the length of the image. Remember, the image is a dotted shape. Now part
yeah,
of the image end up being underneath here. So we have to add both of them to get the full length of the image, and then we divide it by the length of the object. Okay?
Yes.
All right, good explanation. Okay, guys, so let's go over what we just did. When you ask you to find the scale factor of a dilation, you are supposed to look at the shape and identify 2 sides that are corresponding. Now, in your examples here, they give you the sides that were corresponding. Some examples, they will give you all the lengths of all the sides, and you have to choose which ones to use. Okay? But I don't think that will be difficult for you because you can see which sides are matching. That is here clearly to not be matching with that other side over there. It has to match with the 4 here. Okay? So once you find 2 matching sides or 2 corresponding sides of your object and your image, then you find out what's the image length, what is the object length, and then you divide. Okay, so you find 2 corresponding sides of the object and the image. You find out what is the image length, what is the object's length, and then you divide. Image divided by object. So let's see if our answers were correct, and they were correct. You see how we were right, guys? So they were all correct. Okay, so now I'm going to show you how you actually do a dilation without a graph. And that's the end of our session. Okay, that's the last objective for our session, I mean. How do you actually do a dilation? How do you make a dilation? Like if you have a small shape and you want to get a bigger shape, or if you have a big shape and you want to get a small shape, how do you go about doing the dilation? Okay,
You
first
chip
of
off
all,
on
listen
move
carefully.
parts.
First of all, every dilation has a center. Now, a center is a point from which the dilation occurs. So from that point, you see if the dilation is a reduction or image. Well, the scale factor determines if it's an enlargement or reduction, but it is from the center of dilation that you actually perform that transformation. Now, if your center of dilation is 0, 0, which is the origin, you do not have any work to do. If the center of the dilation is not 0, 0, then there are some steps you have to follow. right? Some steps that you do not know as yet. But if the dilation is from the center 0, 0 or the origin, the only thing you have to do is multiply each coordinate of each point by your scale factor. I'm repeating. If the dilation has a center of 0, 0 or the dilation center is the origin, all you have to do is multiply each point. Now remember, each point have an x and a y. So you multiply each coordinate of each point by your scale factor. So what do I mean by that? In our example here, we have the point B, 2, 3. If I want to enlarge this shape, and they told me that my center was 0, 0, to get the image, which will be B prime, I would say 2 times 6, 12, 3 times 6, 18. Okay.
Hey boy, who's still good at books in there?
Um, okay, so if they tell me my center is the origin, and they tell me, or they tell me 0, 0, and they tell me the scale factor is 6, all I have to do is multiply 6 by the 2, and then multiply 6 by the 3. What would be my image point B prime? Somebody?
It's 12.
Remember, a point has two numbers, a x and a y.
12, 18.
7, 18.
12, 18. Very good. All right, so you
Yes, Daddy.
multiply each part of the coordinate by the scale factor. So you see your answer is correct, 12 and 18.
Yes, miss.
All right, what about the second one? 6.
It's 0.
Miss, that's how we find the enlargement or the dilation?
That's how you do. Well, the dilation and enlargement is the same thing.
Okay.
Yeah.
So if is a dilation, you have to divide by 6 instead of multiply, no?
No, you never multiply. You never divide, sorry. You always multiply.
Okay. Understood.
Yeah. You only divide to get your scale factor. Okay, so what do you think the answer would be for this one? You all started, somebody said 0. A prime is 0. And what's the next number?
0, we just now.
Okay.
I think 0, -2. Or
Okay.
0, 0.4. So
Very good. 0,
So for the second one, it have like a point there.
-2. Look the answer, people. So it's correct. 0, -2. Because when you multiply -5 times 2 over 5, so you say -5 over 1 multiplied by 2 over 5. So -5 times 2 is -10. And 1 times 5 is 5. So -10 over 5 is -2. All right, so you would get 0, -2. So this is how you actually perform a dilation when the center is 0, 0. Notice how many times I said that. Remember that your center is not always the origin, or it is not always 0, 0. Okay? Your center may differ. It can be 0, 3, it can be 1, 2. In the example that they will give you, they will tell you exactly what your center is. But if the center is 0, 0, you do not have any additional lines to draw on all the other steps that are involved when the center is not 0, 0. All you have to do if the center is 0, 0 is multiply by the scale factor. All right? And then everybody here can multiply, so that should not be too difficult. All right? Now, the center here, which I believe I said already, is the point from which all the other points will be expanded, or all the other points will be reduced, can change. So remember that. However, if it is 0, 0, what can you do? Someone tell me.
It's multiply.
Multiply by the
Scale factor.
Scale factor. But if it's not 0, 0, you won't be doing that.
Yes,
Okay?
miss.
Only if the center is 0, 0. Now, Normally for your multiple choice exam, if they have a dilation question, your center would be 0, 0 because you'll not be able to do all the different steps you would have to do if the center was not 0, 0. So your multiple choice exam, if you have a dilation question, more than likely your center would be 0, 0, and so you would multiply by your scale factor. Now, before we continue, notice that when the scale factor was more than 1,
So
the
Miss,
points got
Miss,
bigger.
Miss.
Yes.
So the 6 and the 2 5, that was there. That was the scalar factor.
Yeah, these were the scale factors.
Okay.
Yeah.
You should proceed now.
Okay. All right, so that is an example on a graph. Now, if you have it on a graph, again, notice they told you that your scale factor is 0, 0. So everybody should have, do you have your graph papers with you guys?
No, Miss my bookie.
Yes, miss.
Okay. So this,
Yes, Miss.
all right, no problem. This question here is actually what your homework is, but I'm going to go through it with you before. So they told you here that your pentagon has its PENTA and its image P prime, E prime, N prime, T prime, A prime for dilation with center 0, 0. So when you see that they say that the center is 0, 0, you can say whoopee, because then all you have to do is multiply by your scale factor. All right, so the vertices of penta, PENTA, are this. So they want you to perform the dilation. How are you going to perform the dilation? Can someone tell me?
Multiply the 2 points x and y by 0.5.
Very good. So can someone tell me? So 5 persons can answer. So one person, can you tell me what would be P prime?
Me just what I'm doing now.
Okay, so you give me P prime. Somebody else work on E prime. Next person work on N prime. Then we need T prime. We also need A prime.
So Miss P prime is 0 and 2.
Very good. P prime is 0 and 2.
And 2.
Okay, what about E? E prime. 0.5 is like saying a half, eh? Remember that.
Yes, miss.
So if that's the case, Miss, E is 3,3.
Very good. E prime would be 3,3. What would be N prime?
2,0.
Very good. 2,0 would be N prime. What about T prime?
0, -2.
0, -2. Very good. And A prime?
-1, 0.
-1, 0. Good. So we did all of the images by multiplying each of the object points by the scale factor. In each point, we multiply the x by the scale factor and the y by the scale factor. Now, for your homework, what you're going to do for me, and these are the points here. So all our points were correct. What you're going to do for me is actually graph it on graph paper. So you're going to graph for me the point P, E, N, T, and A. Then when you are done, you are going to graph your image. You can do it all over. If you know that other persons gave the answers and you were still working on it, then you have an opportunity to do it yourself. So multiply each point, each coordinate of each point, the x coordinate and the y coordinate of each point by the scale factor 0.5. Get your image, P prime, E prime, N prime, and so on, and plot it on the same graph. When you plot it, you will notice that it is actually an enlargement, a reduction, sorry, because that's 0.5, that's less than 1. It's actually a reduction of your first point, PENTA. Also on that same graph paper, I want you to label the center 0, 0. Label it C for me for center. Because when you are doing dilations, you must always show them where the center is on a dilation. Now, the center is very, very important because even though your center in the examples that we have started with are 0, 0, the center is actually the fixed point, the most important point where from which the image is going to be expanded or it's going to be reduced. Okay, so because of that, you have to label your center. So let me go over that again. Everybody, wherever your center is, mark it C, label it C, then plot your objects, do the working to get your image, and then plot your image. And I want to see your graphs the next time. So the next time, hopefully, we can share our screens and everybody can show their graphs. Or if not, can you scan your graphs and send and email it to us?
Which I mean scan, like if a scanner.
I take a picture, or you can, yeah, some phones have cam scanners, an app where you can just take a picture and it will make it like a scan document. Or if you have a printer at home, you can scan it. Just for us to see your object and your image with your center labeled.
Okay, miss.
If you can. Okay. All right, guys. So I believe that's it. Yes. So that's the end of our presentation on dilation. Okay, what did we do today? We started off with, for those of you who were late.
Sorry.
Okay. All right, so for those of you who were late, guys, we started off with reflection. We did a quick review. We compared the reflection and translation. Then we went through how we would do it on a graph. We just did a quick review of that. Then we spoke about describing the reflection. We said that when we are describing a reflection, we have to first of all say that it is a reflection. The transformation is a reflection, or it is a reflection. And then you must also say what the mirror line is. So you must say it is a reflection over the x-axis, or it is a reflection over the y-axis. Or you can say it is a reflection over the line x equals something. If you notice, it's not the x or the y-axis. It may be the lines x equals something if the line passes to the x-axis, or it may be the line y equals something if the line passes to the y-axis. For you to first of all know it is a reflection, you have to notice if it was a flip. All right, and how you know for sure it's a flip, you will notice that the object and the image will be pointing in opposite directions. After we did that, then we went into what a dilation is. It's a reduction or an enlargement of a shape. And we also learned that the shape of the object stays the same, it's just the size that will change. We also learned that what makes the size change is the scale factor. If it's more than 1, then the shape will get bigger. If it's between 0 and 1, then the shape will get smaller. Okay. Your enlargement can also have a negative scale factor. We'll go through that during your next session. All right. We'll go through that for your next session. Yes. All right. So after we spoke about our scale factors, whether it gets bigger or smaller, we also looked at how to find that scale factor. First, to find our scale factor, we have to look at the image size and the object size. So if the object length is 10 and the image length is 20, and we say 20, the image divided by the object 10, and then we'll get the scale factor 2. It is always your image divided by your object. All right. Also, we notice in our examples that we have to be very careful when we are getting the length of our image, because sometimes the object might be lying on the image and we may have to add. Your pardon? Okay, mute if you accidentally put on your mic. All right, so then we also notice that sometimes we may have to add to get the full length of the image. All right, before we do the working, and the working is what? The working is image divided by object. Finally, we went through how we can do an actual dilation when the center of the dilation is 0, 0, or the center is the origin. All right, the origin, another name for the point 0, 0. When we notice that we have to do a dilation when the center is 0, 0, all we are expected to do is multiply the x and the y of each point by the scale factor. And the answer we get will be our image. So if we have a 1, 3, and our scale factor is 2, our a prime would be 1 times 2, 3 times 2. And so our a prime would be 2, 6. So once we are dilating over using the center 0, 0, we just multiply by our scale factor, and then that will give us our image points. Remember, that is not the same method if the center is not 0, 0. Okay, and you'll go through that in your next session. All right, do we have any questions before we end this class?
No, miss.
No, miss.
No, miss.
No, miss.
Okay, so I
Miss,
hope
just to rectify the stuff we have now, we just have to plot it on the graph, right?
yes, the work you have to do right now, you have to, well, some persons, I'm pretty sure some persons did not get to finish the working because some of you are working very quickly. So I'm saying for those who did not get to do the working themselves, go through it, practice multiplying the points by the scale factor for yourself. All right, and then plot your image. So everybody will be plotting the object, the PENTA. Also, I want you to plot the center and label the center C. And then work out your image and plot your image. That's it.
Yes, miss.
Okay, well, the center should be 0, 0.
Yeah, the center is 0, 0. Okay, guys. All right, guys. So that is it. I'm going to post that PowerPoint here in the Google Classroom right now. And so you can go over it again and interact with it. It
Yeah,
has
miss.
some like images getting bigger and small and whatnot. Okay, guys. Thank you for your attendance today. All right. Today the behavior was good, so I have no complaints right now. Okay,
Yes,
so
miss.
continue that, and then we'll continue learning, and have a good day. Bye bye.
Yes, miss. Same to
Bye.
you.
Good day, miss.
Have a nice day, miss.
Thank you very much. Bye bye.
Bye, miss.